Hey guys, welcome back to the channel. We are going to be continuing the Fysetc Venture XL build, where we left off last time as we put the Z motors and the Z idlers on the unit. And now we are going to be continuing. The next step is to do the gantry. So we will be starting 2.3, the gantry components, again using the wiki because that seems to be the most up to date. The GitHub is not updated as much as people would like, and it probably should be because if they're putting this unit out there, they should probably stay on top of the docs at least. Changing parts and such is something that obviously needs to be done, but more importantly, the documentation should be a little bit better. Okay, so let's go ahead and get going. If you'd like, you can follow along. We're just going to start at the top and go from there. So it goes 2.3.1 A motor assembly. We have all the components here. I got the screws over here. That what you can see, I have everything laid out. So let's see what we have. One thing I'm noticing on this documentation, unlike the other ones for the Z motors, they at least kind of guided you step by step of how to put it together. This one, they just throw the exploded diagram at you and say, okay, that's what you need to do. So it's not a huge problem, but again, when it comes to something nice to have, definitely would have been nice if they just did more than just throw an exploded diagram at you. So, let's see. Okay, so that's the right side. This is the left side. Something interesting I'm noticing, those both say L on them. And these both, well, one of them says R, stamped right up here. And this one doesn't say anything. Okay. So are these both, do these go together? And then you have these ones. Let's hope that the documentation certainly clears that up, which it does look like that they both go together. So we are starting with these ones. And you can tell because these have a little notch here, which these ones do not have that notch. They're just tapered off over here. Okay. So it doesn't look like it matters which one I start with. They're both exactly the same, so it has it in a diagram blown up like this. So we'll start from the top down. We'll grab an M5 by 18 button head cap screw. 5 by 18 button head cap screw. An M3 by 18 socket head cap screw. And an M5 and an M3 T-nut. And we need one of these. And it seems like all of these are exactly the same. All of these are exactly the same. So we'll just grab one of those. And take this here. And this is going to be the M5. And I'll take this one here. You know, if you got to be good at something, I would rather it be guessing, because I'm a good guesser when it comes to doing stuff like this. Okay, so the M5 is 3 millimeters. The M3 is 2.5. Okay, so after you put that plate on like that, there's the 2 screws. With those on there, I just locked them down just so, you know, just tight, not tight, just snug, just to hold them in place so they don't go flying around or don't fall off. Then, so we got an M3x8 flathead cap screw. Is in this corner. You can definitely see where the flathead cap screws go because they're tapered, so that helps a little bit, but it's hard to tell what that goes into really. Let's okay, I'm gonna do all the stuff that is very simple, like with the T-nuts and everything, and then I'm sure I can figure out the design of what they had intended for here, for the bearings and all that stuff. So M5x12 button head cap screw. M5. Yeah, and this is my first printer build, so never done this before, and I just went for it. A lot of people are like, yeah, I definitely wouldn't do this as your first printer build. Well, I need this, so there's no option. Okay, I gotta figure it out. M3x12 socket head. M3x12 socket head holds these on. And a lot of this stuff, just until done putting it together, I do plan on Loctiting it, but I'm not going to Loctite it right away, just in case I have to change screws or something. But I can always go back and, you know, stuff like this, take this apart, throw some Loctite on there, and then put them back together. Okay, so the bearing, there's going to be a bearing here. A bearing here. These two have sleeves. Oh, two bearings back here. And then a bearing over here. Okay. And then these two have sleeves. Need one of these for the one bearing. What I am noticing is if you go back and forth from the blown up diagram and then look at the complete one, it kind of looks like it's better to kind of bounce back and forth like that, I guess you could say, because it makes more sense. You seeing it put like actually together. Okay, it looks like the difference between some of these are, oh, some of them are tapped. Or, yeah, some of them are tapped and some of them are through. Okay, I see. So these are through. Oh no, those are tapped. registered. Yep, these are okay. This is definitely tapped. This is tapped. I can imagine these are the ones that it goes, because these aren't tapped. Okay, these aren't tapped, so these got to be the ones that it goes through. Right here. That one's tapped. Three by 8. So 3 and M3. So I'm gonna grab a micrometer because it says that the outer dimension is 5, outer dimension is 6 on a couple of these, 5, 6. I'm gonna grab a micrometer and just see if I can comb through the weeds on which ones are which. It would definitely be nice, Fysetc, if you watch this video, if you could label these like you did the screws and everything, put like 1, 2, 3, 4, 5, whatever number correlates with that diagram that you have there. I mean, that would just be a huge help for folks that are putting this together. Because obviously I can comb through the weeds and try and figure this out, but it would just make things a lot simpler. Okay, so that's 6. Okay, 6 by 25.8 by 3.5. Okay, so these are number 1. So there's 3 number 1s. So now it kind of is making a little bit more sense. It goes like this. There's one on these two and this one. And then that's a bearing stack and that's a bearing stack. This is this bearing and that is the dual bearing. Yep, and those both have flathead cap screws because those are threaded. So those are probably the M3s. So if I take, let's go back to our diagram here. So this goes right here. And that should be one of these M3 flathead cap screws. The M3 flathead cap screw is a 2mm. Okay, so we have that one. And now we gotta find which one is number 3. So number 3 is 5. Okay, so that makes it a little simpler. Because that one's 2.5 threaded. So let's see. Actually, there's only 2 of those. Let's see. Okay, 6mm. So that's not the one that we're looking for. Oh, I see it. So it said that there's 12 of those stubby ones. So I probably, let's see, 1, 2, 3, 4. So yeah, there was 12. Okay, so those are what it looks like. So I'm looking for the one with 2, and it's gonna be 5mm. So it's gonna be the skinnier one, I think. Okay, so it should be this guy. Okay, I see what you did here, Fysetc. I see. Those, I thought those were bearings. Those are a top-down view of this sleeve. So when you see those circles below it on that diagram, that is a top-down view of each sleeve, okay? Then it tells you how many there are. Like we use 12 on the Z motors, and that's why there's 12 of those. Now, okay, now it's making a little bit more sense. I would definitely recommend a micrometer. As you see, I'm sitting here combing through the weeds trying to figure out what the heck they had in store for this thing. So definitely would recommend that, no doubt. Because that's the only way to figure out, unless they start putting labels on stuff, that's the only way to figure out what is what. Okay, so, and then a bearing stack goes here. So it looks like they have one washer, set of bearings. Another washer. Set of bearings. And then there will be another washer that goes on here. I don't know if it'll stay if I put it on. Let's see. Oh, I guess it will. Okay. And we'll get this one. Okay, so that's how that looks. There's also a shim, which it doesn't tell you what shim, but it only identifies the 0.5 millimeter shim. So I'm guessing every time there's a shim, that's what it's looking for. So then there's 3 screws. We'll just get these out of the way. M3x8 button head. M3x8 button head, 2 millimeters. They go on this little plate here. I wonder if that's supposed to be difficult to put in, because it goes in like halfway and then it's a little bit difficult. Okay, we'll leave those off to the side here for a second. M3x38 socket head. These are what are going to hold those sleeves on that I have standing up next to it. So looking at this piece, they go up this way. These go on here. Okay. And we have to prep the right side now. So I'll prep the right side before we go ahead, and then we have to put this together like this. So I'll prep that. So we got M5 by 18 button head. One of these little gizmos here. So the other side has a different setup than this one. This side has this with the 3 holes, and the other side has this with the 2 holes and the little notch. So these go up, the notch up, and these go through. M5. And again, I'm just snugging these just so they don't fall out and cause a headache for me. Just put them a little snug, just so they stay out of the way. Then we have M5 by 18 again at the bottom. Okay. So again, knocking that out right away. Those are M5 by 18 button head cap screws. So, and then M5 T-nuts on the back. The top has that little notch in there. Okay. The bearing stacks, the ones with the bearings on them, are going to be met with these 45s. The one there and then one on the corner here. You can tell because the flathead cap screw goes on there, and it's shaved on a 45. And then the M3 by 38s, those go into the motor. Yep, they're gonna go into the motor in those holes there. Again, only utilizing 3 motor mounts. I'm sure for obvious reasons with the other pulleys and stuff, but I wonder if there's any performance loss or contorting. I wonder what the modal analysis looks like of the twisting of it, since there's only 3 and not 4. I could be overthinking it, but definitely could be cause for concern at speed. Okay. Okay, so I'm gonna try this one more time with these 3 little screws here. Not sure why it gets halfway through and then it's a little bit hard to get through. It might have just been that screw, although I am trying a different hole on this one. So let's Let's try a different screw. Let's see. Maybe it's a screw. Or it could be the paint. It is definitely a little bit harder than it should be, in my opinion. It's aluminum. I don't see any shavings coming through, so maybe it is just the coating. That's such a small little screw. Yeah, there's no shavings or anything coming through, so that's good. Yeah, it might have just been that one screw because these two other ones are going in just fine. Just a little bit tighter than it should be, I feel. So let's grab another one of these, a different one of these. Okay, so all three of those are in. So actually that piece has to go here. Which, it's funny, it shows it in the completed one, but it doesn't show it anywhere. This little piece that goes in that sticks up, it shows it on the completed one, but it doesn't show it in the exploded view. You can see it just shows, and if you're following along, you can see it just shows the two screws going in. It doesn't show any piece of it going through. So one more change for you, Fysetc. Go ahead and put that in there. A little confusing. And Fysetc, if you do end up watching this video, this is not me complaining by any means. This is me trying to help you help others that might be afraid of putting this printer together. Because, you know, a lot of people said this is not a beginner-friendly printer. And I have no choice. So I have to put this together. Oh, okay, so actually I can't put this on because it'll block the two screws that go down. Okay. So if I were to put this on, this would block the two screws that have to screw those two assemblies together. So really you're almost better off just waiting to put this on all together until you throw those screws in. So then it shows the motor. Yeah, let's see if I can get this So if we put that, because I can do the motor after, but then I can hold it together with the flathead cap screws. So now that I have a good understanding of what's going on here, I'm going to go ahead and take some of this stuff off, and I'm going like the bearing stack mounts, those pillars that they sit on, I'm going to Loctite those, because now I have a very good understanding of what's going on here. And again, right now I am Loctiting the flathead cap screws that we'll be holding the bearing stacks on. So those are the two there. You can see the one with the half shoulder and then the other one that sticks up. Okay. Now I'll go ahead and put this bearing stack back here. That goes on like that. And then I can go ahead and this one, put this stack back on. Make sure, yes, there is a washer between those. And there is that. Okay. So now that those are on, I'm not going to tighten the screws that are holding this together because I want to ensure that it lines up with the other one so it'll be free floating. So what I will be doing is tighten these flathead cap screws that are on the top of here that connect those two together. And then once I get those two aligned, then I'll go ahead and tighten these up to kind of pinch down on it. you know what I'm gonna do? I'm gonna snug those two up ever so slightly snug, just to hold it. And then I'll put the other one in again, just to hold it, and then I'll put those in there. Okay, so now we can put that one in, put this spacer between here. It's very tight. I'll back this out a little bit. Okay, so now go ahead and tighten this one. Again, that's going into aluminum. You definitely don't want to over tighten these. There'll be bad news bears all around. We call them Fysetc and waiting 2 weeks for something to come in. Just kidding. I don't know how long it takes, but I could imagine that it's not overnight. Okay, so now what are the ones that go on the other side? So we got M3x12 socket head. Oh. Put those loosely in there. And I think I'm going to do the motor and then the rest of that. Yeah, that shouldn't keep me from doing anything. So go ahead and grab a motor pulley. And there's only 2 of these. The reason you can tell that is because of the opening. These are the smaller shafted ones. Okay. And I also have the double shear parts. There they are. As you just heard everything fall and hit the floor. So here are the double shear printed parts that I printed. Everything's in ABS. This is actually Flash Forge ABS, as you heard me talk about earlier. This stuff is phenomenal. I matched it up with some of the other stuff. Like I have mine that I had printed that I'm going to be using here in a second. And then I have Fysetc's version, which you could tell it's all shiny. PETG, definitely not ABS. You can see mine is not shiny. It might look shiny, it is not. It's like matte finish. So we'll go ahead, this goes upside down. And I'm just gonna put these very light, because I don't want to mar the shaft in case I gotta move this. So I'll just put that very light in there. So it shows it. The exploded diagram is like this. And it shows this electrical port pointed down. Okay? There's a little circle on the rear end of the motor, and that's the electrical connection that goes down. Okay? So this is going to go in here. I will throw some Loctite in here. So we got, let's see, this one, this one, this one. And I'm going to grab a paper towel. Yesterday I used the shorts. Today I got a little bit nicer pair of shorts on. Be going to lunch here shortly, so I don't want to get the shorts all dirty. Yesterday those were work shorts anyways. So, okay, so electrical connection is down. This is going to go in like this. And you know what? Does this turn? Okay, yeah, this turns. Okay, yeah, this turns. These M3 by 38s, they're going to be a 2.5 millimeter. And again, I'm going to be using the cross torque pattern, or you just get everything lightly snug. There's only 3 on here, but I want to make sure that this evenly sucks up to the motor face. So just giving it a little bump, going around, and I'm going to do that all the way around until they are tight, doing a little bit, a little bit, a little bit at a time. There's actually like a little bit of play. I don't know if it's just not tight yet, but it seems pretty tight already. So I'm not sure why there's a little bit of play in there. Yeah, you can move each screw. Not too sure why there's that little bit of play in there. The whole thing can kind of rock. The whole motor can rock. I don't know if you can see that. You can kind of see if you crack a little bit. And these, I'm actually going to have to put these on later because they're going to have to be blown up a little bit. Everything is tight. Except for these. That is very interesting. How it's... Yeah, and these are as tight as they're gonna get. They're not getting any tighter. Okay, so what do we do? I wonder if this was where people had problems with the screws being too long, as they were here. I wonder if that's where, that's what I'm seeing right now. Because it doesn't make sense why that would be. Yeah, they were definitely bottomed out. You can see the marks down there. Let me see if there's an M3 by 38 socket head and different socket. See if M3 by 30 would work. Nope, definitely not. Definitely not. Well, pooey. that is just a little bit too long. And it probably should be like M3 by 36 maybe, to just give it that little bit extra. Okay, so what are we gonna do? Maybe they weren't cinched up right or something. Let's. No, it's just a little too big. Yeah, because these are recessed in here. Okay. So here I'll give you a little view. So these screws are recessed in here. Okay. Now, if you watch the screw head, and I'm hoping that you'll be able to see it, you can see it moving. Try and get you the best view I can here. You can see it moving within that hole, okay? Because it's loose. And it's not loose by much, but it's loose. It's loose just a little tiny bit, like 1 or 2 millimeters. The one thing I could do is I could file the screws down just a little bit and then clean them up and hope that should fix it, because the screws just seem too long. Let me see if there's anything in here about that. Okay, guys. Well, what I'm going to do is I'm going to do some investigating on this, see if I have to shorten those screws, if there's another viable option. I'm also going to look to see if anybody else had this problem. I know I had briefly seen some other stuff that they had supposedly solved this problem because people were putting spacers in. I'm not sure if it's exactly pertaining to this or if that was from a different assembly of something else. Okay, so I hope you liked the video. I'll be back with the solution to this problem, and I'll go ahead and get this figured out. I'm going to consult with a couple other guys that I talked to and see what they can come up with or guidance in any way. If they don't have anything, I might file these screws down because it's not by much. It's probably a mil or so, which shouldn't affect the integrity of the screw itself. Okay, so hit that like button, subscribe, and we will have 1.5 of the Gantry, the version 1.5 of the 2.3 Gantry component assembly next time. Thank you. Have a wonderful day.